I blast no more. Yo, they call a motherfucker John Doe. Now when I hit that switch, I'm bouncing. More bounce to the ounce and I'm climbing. When I hit that switch, I'm bouncing. More bounce to the ounce and I'm climbing. When I hit that switch, I'm bouncing. More bounce to the ounce and I'm climbing.
Section. So the first one is going to be the following. So we're going to integrate over the domain y over x, and we have dA. Okay, so we're also given that D is the following. So D is, and we're given this graph. Okay, so I'm going to, I'll tell you beforehand, this is going to be a circle because the picture might say differently. So pretend this is a circle, like a semicircle, right? For the top half, and this is, it intersects at -2 and 2, and this is 2 up here. All right, so this is our y, and this is our x, and this is 1, and that's -1. Okay, so our domain, though, is only, hold on here, let me get a line going. Our domain is this little section right here. Okay, so that's D. All right. Okay, and we might or might not be given, well, okay, I guess we'll figure it out. But so given this, we know that the equation of a circle is x squared plus y squared equals r squared. Okay, so knowing this, our radius for this circle is 2. So if we plug that in, we get x squared plus y squared equals 2 squared, which is 4. And if we solve for y, we'll get that y squared equals 4 minus x squared, and thus y equals positive or negative square root of 4 minus x squared. And in this case, we have the positive square root because we're on top, right? We're in the positives, so we can get rid of the negative here. So that is the equation for the top curve. Okay, so this is y equals positive. You don't have to write the positive if you don't want to. 4 minus x squared. Okay, and the bottom, as far as y, is going to be y equals 0. So that one's pretty simple. Y equals 0. So this is like our g2 of x, the top one, and this is like our g1 of x. Okay, and if you can't tell yet, I'm setting up for a vertically simple domain here. Okay, technically you could do horizontally simple, but that would just get a little bit messier, I think. Yeah, so anyways, and I did it this way because the bounds for x are pretty clear. X just goes from 1 to 2. So, whereas in the other case, for if you wanted to make it horizontally simple, you'd have to figure out where it might actually be 1. Might be 1 as well. Anyways, I'm just going to go this way, and this is a vertically simple. I'll write it out here. Vertically simple domain. And just as a general rule for any problem, if you find that one way works, like this one, I just chose vertically simple. If that way works, then just go with it and find your answer. You don't need to try to see if it's horizontally simple or not, and vice versa. If it works horizontally, then there's no need to do it vertically as well. I mean, you can if you want to practice more for a test or something, or just to understand the concept better, but there's no need to after you solve it the first way. So now that we have this, we have our y is bounded by 0 on the bottom and the circle on the top. So the equation for that was positive 4 minus x squared. And we can see from the picture that x goes from positive 1 to positive 2, right? So 1 to 2. Okay, so we have our bounds, and we also know that our f of x, y is equal to y over x, because that's what we're given, right, here at the top. Okay, so now we can set it up to solve, and I will do so on the next slide. Okay, so we're going to have the constants on the outside, 1 to 2, right? And then our more complicated bounds on the inside, which is 0 to radical 4 minus x squared. And then I'm going to rewrite y over x as y times x to the -1. It's just easier to look at for me personally. So then we have dy dx. Okay, so let's start integrating here. We have the inner integral, and we're going to treat, since we're integrating with respect to y, we're treating x as a constant. So treat x as constant, okay? And that means we're going to have 1 to 2, and then x to the negative 1 just stays there, because that's like a constant. I don't know why I have that little dash there. Okay, there we go. And then when we integrate with respect to y, we get 1/2 y squared, and y is going to range from 0 to 4 minus x squared. Okay, do I have, yeah, I have enough parentheses, and dx is on the outside. Okay, so now what we have is, I'm going to bring this 1/2 out in front. Okay, so 1/2 just sits there, and then we have 1 to 2, and x to the negative 1 is just 1 over x. That's also just sitting there, because that's like a constant right now. And then we have y squared. So in this case, we have square root of 4 minus x squared, and all of that squared, minus 0 squared, which is just 0. Okay, and then what we end up getting is 1/2 from 1 to 2, and then a 1 over x, and then square root squared, those cancel out. So then we get a 4 minus x squared, which came out of the square root. Okay? So then from here, what we can do is just distribute this 1 over x into each term. Alright? So then we get 1/2, and then our 1 to 2 is just staying there for now. And then we get a 4 over x minus an x squared over x, and I'll simplify in the next step. Okay, 1/2, 1 to 2, and then this is like a 4, well, I guess I'll just leave it 4 over x, hold on, 4 over x, and then minus a normal x, dx. Okay, so now we can just integrate, continue integrating like normal. So this is a 4 times ln x, and you don't need absolute values here because we have x goes from 1 to 2, so it's not that big of a deal. Nothing's negative there. So we don't need the absolute value sign. You could just do parentheses if you want. Minus 1/2 x squared, as x ranges from x equals 1 to x equals 2, right? Our bounds. Okay. So then when we simplify, we get 1/2 4 times ln 2, okay? And then minus 1/2 times 2 squared. And then we have a, okay, I'm going to squish this in, sorry. 4 ln 1, and then a minus 1/2 1 squared. So that's just 1/2, okay? All right, so then we have, let's see, what we're going to get is our final answer here. So then this distributes in, so we get, I'm going to distribute the 1/2 into each of the terms here, that, and then to both of those. So this is a 2 ln 2, 2 ln 2, and then for the second term we have negative 4 over 4, so that's a minus 1, all right? And then for this last term, okay, so for ln 1, that's just 0, and then we have a plus 1 over 4 times 1/2, wait, okay, no, sorry, plus 1/2 times 1/2, which is a plus 1 over 4. Okay, so our final answer, and the good thing about logs is you can bring the coefficient up and make it an exponent. So this is like ln of 2 squared, which is ln 4, okay? And then this turns out to be a minus 3 over 4. Okay, so that's our final answer for that problem. All right? Okay, so now on to the next one.
Cruising, walk, stay up on the nuts and the bone. Pussy nigga had beef, knocked out his teeth. The motherfucker should have stayed his ass home.